Hello children, I am Mrs. Apurva Kulkarni from Deccan Education Society's D.E.S Secondary School, Tirak Road, Pune. Today we are going to learn periodic classification of elements, Science 1, lesson number 2. Now why classification is needed? Children, imagine if you go to a library to get particular book, and if books are not organized properly, arranged properly, what will happen? Definitely, it would be very hard to find particular book. So similarly, at present, today, 118 elements are known. To make the study of those elements easy to us, scientists tried to classify those elements. So let us begin with our study, periodic classification of elements. To learn more in detail about periodic classification of elements, we must recall something which we have learnt already in previous classes. So let's recall. Children, all of you know there are states of matter which you have learnt. Those are solid, liquid, gases. Plasma state is also there. Now solids, molecules are very close to each other. In liquid, the distance between molecule is more as compared to solid. In gases, the distance is more. Now what is plasma? At very high temperature of stars, atoms loses their electrons. The mixture of electrons and nuclei that results into plasma. Okay, we can say it is an ionized gas. There is also fifth state of matter, Bose-Einstein condensate. But we are not going to go more detail to that. What is an element? Only one kind of an atom in free state or combined state. And what are the types of elements? We know metals, non-metals, metalloids that we have already learned. Now what is an atom? We have studied the structure of atom, history of atom. Many scientists tried to find what is inside the atom. So what is atom? It is the smallest particle of an element that can exist. And the structure of atom? Atom consists of a central part, that is nucleus, and it is usually surrounded by one or more electrons, as you can see here in the diagram. Each electron is negatively charged. The nucleus is positively charged and contains one or more relatively heavy particles known as protons and neutrons. The basic structure at the center, nucleus is there. Inside the nucleus, protons and neutrons are present, and this nucleus is surrounded by electrons, as you can show it here in this picture. Now what is atomic number? The number of protons in the nucleus of an atom. Now remember, as atom is electrically neutral, number of protons and number of electrons are equal. So atomic number you can say as number of protons or number of electrons in an atom. Atomic mass number. What is atomic mass number? It is the total number of protons and neutrons together. Those are also called as nucleons, you can see. So number of protons and neutrons in the nucleus is nothing but atomic mass number. So let us revise those things again. Elements. Elements are chemically the simplest substance because only one kind of atom is present in it. Hence cannot be broken down by using chemical reactions. Elements are chemically the simplest substances and hence cannot be broken down using chemical reactions. You can see molecule of elements O2, N2, that is oxygen and nitrogen. We write it like this. What is compound? A compound is a substance formed when two or more elements are chemically bonded together. So in the compound, proportion of constituent is fixed. So molecules of compound like water, magnesium oxide, because here hydrogen and oxygen present in the water, magnesium and oxygen is present in magnesium oxide. So it forms a compound. What is mixture? A mixture is a physical combination of two or more substances in which the identities are retained. For example, we eat bhel. That is also a mixture. Lemon juice. That is a mixture. We can retain the properties of constituents again. Now, after revising all these things, let us move towards the classification of elements. Initially, the classification of elements was based on just metals, non-metals, metalloids, etc. As the knowledge about the elements and their properties went on increasing, many scientists tried to find them. So this is Doordarshan's tried. In 1867, German scientist Doordarshan suggested that the properties of elements are related to their mass number. So, it is related to their atomic masses. What he suggested? He arranged the three elements in a triad and in an increasing order of atomic mass, and showed that atomic mass of middle element was approximately equal to the mean of atomic masses of other two elements. So this example is given: lithium, sodium and potassium. So he arranged these three elements together. What is atomic mass of lithium? It is 6.9. Atomic mass of potassium is 39.1. So if we take mean of this, that is 6.9 plus 39.1 divided by 2, we will get 23. So that 23 is nothing but the actual atomic mass of sodium. So similarly, these three elements, CaSrBa, ClBrI, so those three elements are arranged in such a way that the atomic mass of middle element was approximately equal to the mean of the atomic masses of other two elements. So here is this periodic table, and here in this how these three elements are arranged according to their mass numbers. But all the known elements could not be classified into the Doordarshan's triad. So that's what this Doordarshan's classification was not accepted. Now, Newland's law of octaves. John Newland was English scientist. He correlated the atomic masses of elements to their property in a different way. Now, Newland arranged the elements known at that time in an increasing order of their atomic masses. So, according to Doordarshan also arranged according to their mass number. Newland also arranged according to their atomic masses. Now, what he found that every eighth element had properties similar to those of first one. In the year 1866, Newland arranged the elements known at that time in an increasing order of their atomic masses, as we have discussed. It started with the lightest element, hydrogen, and ended up with thorium. And what he found? That every eighth element had properties similar to those of first one. Newland compared this similarity with the octaves in the music. He called the similarity observed in the eighth and the first element as the law of octaves. So how he compared it with music? In the Indian music system, there are 7 main notes, namely Sa, Re, Ga, Ma, Pa, Dha, Ni, and their collection is called as a saptak. The frequency of notes goes on increasing from Sa to Ni, then comes to the Sa again. So that is upper saptak. We call it as Tara saptak, Manra saptak, Madhya saptak and Tara saptak. The frequency of Sa is different, but note is same, Sa, at the double of the frequency of original Sa. It means that notes repeat after completion of one saptak. The 7 notes in Western music are also Do, Re, Mi, Fa, So, La, Ti. It is like Sa. The note do, having double the original frequency, comes again at the 8th place. This is the octave of Western notes. So music is created by variety of the notes by using it again and again. So here is Newland's law of octaves and how he arranged this according to the property of elements. So hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, and again this fluorine. The property of fluorine is similar to hydrogen. So he tried to arrange those elements according to his law of octaves. But limitations are there. That's what his theory was also not accepted. So what were the limitations? The law was found to be applicable only up to calcium. Newland's fitted all elements known in the table, that is of 7 into 8, that is 56 boxes. Now sometimes Newland's placed 2 elements each in some boxes to accommodate all the known electrons in the table. Newland's octave did not have provision to accommodate the newly discovered elements. And the properties of new elements discovered later that did not fit in the Newland's law of octaves. So that's what this theory was also not accepted. So now Dmitri Mendeleev, this scientist tried to find out the classification, how to classify elements. Dmitri Mendeleev was a professor in the St. Petersburg University. He made separate cards for every known elements. He liked to play solitaire game. Do you know that game of card? So considering that, he tried to make separate cards for every known elements showing its atomic masses. He arranged the cards in accordance with the atomic masses and properties of elements, which resulted in the invention of periodic table of elements. So what is Mendeleev's law? The properties of elements are periodic function of their atomic masses. So this atomic masses, again he tried to focus on atomic mass number. So again, let us revise this. The Russian scientist Dmitri Mendeleev developed the periodic table of elements during the period 1869 to 1872 AD. Mendeleev's periodic table is the most important step in the classification of elements. Mendeleev considered the fundamental property of elements, namely the atomic mass, as standard and arranged 63 elements known at that time in an increasing order of their atomic masses. So children, remember this. Mendeleev organized the periodic table on the basis of chemical and physical properties also. So along with atomic masses, this physical and chemical properties of elements also considered. These were the molecular formula of hydride and oxides of the element, their melting point, boiling point, densities of elements, and their hydrides and oxides. See how many properties he tried to find out, he tried to classify it. Mendeleev found that the elements with similar physical and chemical properties repeat after a definite interval. So this is Mendeleev's periodic table, which is given in the textbook. So he tried to arrange those elements in groups. So group 1, 2, 3 till group 8. So he tried to arrange those elements in 8 different groups. And how to write this molecular formula of oxides and hydrides. So write the molecular formulae of oxides of the following elements by referring to the Mendeleev's periodic table. So sodium, where is sodium in his periodic table? It is here now. So how to write this molecular formula of sodium when it combines with oxygen? Oxide of sodium is written Na H2O, like here. Now here superscript and subscript. Right now we write like this, but earlier he used to write like this. Then silicon. Silicon is here. So RO2. So SiR means particular element. So SiO2. Calcium is here. CaO. See the formula. And carbon. Now where is carbon? Carbon is in the fourth group. So we can write molecular formula CO2. So this is how we can write molecular formula by using Mendeleev's periodic table. And similarly, this molecular formula of oxygen, carbon, chlorine with hydrogen, by referring Mendeleev's periodic table, we can write like this: H2O, CH4, HCl. And still we are referring to write the molecular formula of those particular elements. So this is Mendeleev's periodic table. Now you can see here some blank spaces are there. He kept blank spaces. So he arranged these elements from group 1 to group 8. And that is group, and this is the period. So vertical columns are group and horizontal rows are called periods. What is the importance of Mendeleev's periodic table? There are so many merits of Mendeleev's periodic table. So atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, previously determined atomic mass of beryllium, it was 14.09, but it was corrected to this value, 9.4, and therefore the place of beryllium was changed. Now it is before boron. What is second merit? Mendeleev kept vacant places, as I told you before, in the periodic table for elements not discovered till then. But very important thing that he predicted the things. He predicted the properties of elements which were not discovered till then. He predicted those, that atomic masses 44, 68, 72, and not only this, but their properties also predicted. So he named Eka boron, Eka aluminium, Eka silicon, like similar. And later on, we know those elements by their names: scandium, gallium, and germanium respectively. And third merit, there was no place reserved for noble gases in the Mendeleev's original periodic table. However, when noble gases such as helium, neon, argon, etc. were discovered, Mendeleev created zero group without disturbing the original periodic table, in which the noble gases were treated very well. So here, as I told you, Eka boron like boron, Eka aluminium like aluminium, Eka silicon like silicon. So those elements he predicted. Then again, this we talked about beryllium. That's what beryllium is placed before boron. So Mendeleev's periodic table is very important, but still some demerits of Mendeleev's periodic table are there, and those are as follows. The whole number atomic mass of the element cobalt, that is CO, and nickel Ni is same. Therefore, there was an ambiguity, confusion was there regarding their sequence in Mendeleev's periodic table, because Mendeleev arranged those elements according to the increasing order of their atomic masses. So, where to place cobalt and where to place nickel? That was the confusion. Second demerit was isotopes were discovered long time after Mendeleev put forth the periodic table. Now, what are isotopes? Isotopes are elements having same atomic number but different mass number. See, mass number of same element can be different. Those are called as isotopes. As isotopes have same chemical properties but different atomic masses, a challenge was posed in placing them in Mendeleev's periodic table. If same element, same chemical properties of that particular element, where to place? Because those atomic numbers are different. Third demerit. When elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. So the sequence of atomic mass number was not uniform. And last, position of hydrogen. Hydrogen shows similarity with halogen, that is group 17, right now we know. But here group 7, according to him. For example, the molecular formula of hydrogen is H2, while molecular formulae of fluorine, chlorine, that is F2 and Cl2, respectively. So in the same way, there is similarity in the chemical properties also. So therefore, where to place hydrogen, that was a big confusion in front of Mendeleev. So those are demerits of Mendeleev's periodic table. And therefore, this periodic table is also not accepted. Modern periodic law. Right now, we are referring this modern periodic table, which is discovered by Henry Moseley. In 1913 AD, the English scientist Henry Moseley demonstrated with the help of experiments done using X-ray tube that the atomic number of an element corresponds to the positive charge of the nucleus or number of protons in the nucleus of atom of that element. So this revealed that atomic number is more fundamental property of an element than its atomic masses. So what that modern periodic law states? It states that properties of elements are a periodic function of their atomic numbers. Accordingly, Mendeleev's periodic law was modified and atomic number was adopted as the basis of modern periodic table. So this is the picture of modern periodic table. Now, as you can see, this periodic table is divided into 18 groups. So vertical columns are called as groups, horizontal rows which are called as period. Children, we'll write our timetable in such manner. First period, second period, third period, like this. And then Sunday, Monday, Tuesday. In columns we write it. So similarly, you can remember in this way that 18 groups, vertical columns and horizontal rows are called as period. Now this particular periodic table is divided into 4 blocks, as you can see here. So group 1 and 2 belongs to S block. Group 13 to 18 belongs to P block. So group 13 to 18 elements are called as a P block element. Then group 3 to 12, those elements are called as D block elements. And this is lanthanide and actinide series. So those are called as F block elements. So this periodic table is divided into 4 blocks, 18 groups, 7 periods. As we have discussed that this periodic table is based on atomic number. As you can see here, atomic number, hydrogen atomic number 1, helium atomic number 2. Now how to write electronic configuration that we have learned in our previous standard. So relation between electronic configuration and atomic number of an element. In this picture, you can see hydrogen, lithium and aluminium electronic configuration. Nucleus is at the center and electrons are revolving around the nucleus in different shells. So these different shells, what are the electron capacity of different shell? It is given by this formula 2n square. where n is the number of shell. So first shell is K shell, then L, M and N. So capacity of K shell is 2 electrons. Capacity of L, that is second shell, that is 2 into this n square, 2 square, 8 electrons. In second shell, only 8 electrons can be filled. Third shell, 18 electrons. And fourth, that is N shell, 32 electrons can be present. 32 electrons present in it. Yes, as we have seen, energy level, first energy level, this is, as we have discussed, K shell, L, M and N, and capacity is written here, 2, 8, 18 and 32. And at the center, positively charged nucleus is present. Now, here, important thing is every shell is divided into subshell, as you can see here in this picture. So shell 1 is having only one subshell, that is S. Shell 2 is having two subshells, that is S and P. Shell 3 having three subshells, S, P and D. And shell 4 having four subshells, S, P, D and F. So accordingly, electrons are filled in shells and subshells. But these subshells are not included in our syllabus. So that's what, just remember that every shell is having subshell. So children, today we have learned how elements are classified. Definitely, different scientists put their efforts to classify those elements. So today we are referring modern periodic table.